welcome to the third video of the scientific measurement section. This one is on significant figures in math, and when we look at the significant figures, you need to remember that there are two types of numbers: measurements and defined numbers. And when you have a measurement, you have to calculate the number of significant figures, and when you have a defined number, remember defined numbers are counts, conversion factors, or math numbers, and we don't use those. You have an infinite number of significant figures. This section is going to answer that ever popular question: how many decimal places should my answer have? And my response will be just the right amount, at which point you will initially look at me quite quizzically and go, but how many is that? And I'm going to tell you, you follow the rules, and the rules are based upon significant figures. There are rules for two types of operations. The first are the rules for multiplication and division. Those rules are the same for both. And the rules for addition and subtraction. And that set of rules is good for both of those. So for multiplication and division, you want the number of significant figures in the answer to be equal to the least number of significant figures in any number in the equation. What does that mean? Well, the best way to show this is to do an example. So suppose you have a rectangle. The rectangle measures 130.9 millimeters by 47.0 millimeters. What's the area? I'm sure you remember that area is length times width for a rectangle. So you plug the numbers in and you get this value. But this is not the correct final answer. Take a look at what you have. 130.9 has 4 significant figures. 47.0 has 3 significant figures. So the fewest number of significant figures in the equation is 3. So the answer should have 3 significant figures. So you take your original answer and you start the counting of significant figures from the number to the non-zero digit that is furthest to the left. So we know the 6, it will be significant. We know the 1 will be significant. And then we look at the 5. The 5 will be the last significant figure, so now you look to the right of the 5 and you determine, do you need to round that 5 up or leave it? Because we round, we don't truncate. 2 is less than 5, so we're going to leave it, and the correct answer would be 6150 millimeters squared. The order of magnitude of the number must stay the same. So for multiplication and division, you count significant figures. You're given a brick. Brick has this mass and this volume. You're asked about the density, and I'll remind you the density is mass divided by volume. So what is the density of this brick? Please be sure you have the correct number of significant figures or the correct number of decimal places. The correct answer is that the density is 1.77 grams per milliliter. How did we get this? Well, you start with the original, and since we know that density equals mass divided by volume, so we set the equation up. When you do the math, this is the number you get. This is way too many decimal places. So we go back to the original equation. We see that we have 5 significant figures in the numerator, 3 significant figures in the denominator. So our answer should have 3 significant figures. So we look at our original number. We know the 1 and the 7 are going to stay. You look at the 6 and say, do you round up or keep it the same? So with 5, you round up. So the correct number would be 1.77 grams per milliliter. For addition and subtraction, you round to the least number of places in the decimal portion. So let's go back to a rectangle. We've remeasured it and we realize that it's 130.9 millimeters by 47.06 millimeters. What's the perimeter of this rectangle? Well, the perimeter is the length plus the length plus the width plus the width. So we plug the numbers in, set them up to be added. You get 354.12 millimeters. But you notice there is 1 decimal point here, 1 decimal point here, 2 decimal points here, 2 decimal points here. The fewest number of decimal points is 1. So the answer should only have 1 decimal point, and you would write it as 354.1 millimeters. So for addition and subtraction, you count the decimal places and use the least number. So here is an example for you to try. Get the answer with the correct number of decimal places, then I'll walk you through it. Go. Correct answer is 205.85 kilograms. How did we get it? Well, you start with the problem, you set it up. When you do the math, you get this as the answer. But you notice that you have 2 decimal points here, 3 decimal points here, 4 decimal points here, 3 decimal points here. The least number of decimal points is 2, so your answer had better have 2 decimal points. You see that the 4 will be rounded up to 5, and so the correct answer is 205.85 kilograms. Here is a problem for you to try. You got a piece of wood that's 27.75 inches long. How many feet long is this piece of lumber? You know how to convert from inches to feet. Get your answer with the correct number of significant figures. Write it down, come back, check it, and we'll go through it. Go. And if you get 2.3125 feet, your answer is incorrect. If you got 2 feet, your answer is incorrect. If you got 2.313 feet, now your answer is correct. So we know the length of the piece of lumber. That's 27.75 inches. You know that 12 inches equals 1 foot. So if you set up an equation that looks like this, you're going to get the answer. So when you first plug it in, you get the 2.3125. But you notice on the left-hand side of the equation, none of those numbers has 5 significant figures, so this cannot be the answer. You take a look and you go, oh, 1 foot has 1 significant figure, so the answer should have 1 significant figure, so it rounds to 2 feet. But that's incorrect. Why? Because 1 foot over 12 inches is a conversion factor. Conversion factors have an infinite number of significant figures. They are a defined number. So the 27.75 with 4 significant figures is the least number of significant figures, because 4 is less than infinite. So the answer rounds to 2.313 feet. So to review how to do math with significant figures. 1. For measurements, you need to calculate significant figures. 2. For defined numbers, and remember defined numbers are counts and conversion factors, there are an infinite number of significant figures. The number of decimal points for the final answer depends upon the rules. For multiplication and division, this is the long definition, but you can shorten it to count the significant figures, and the answer should have the same number of significant figures as the fewest number you have. For addition and subtraction, here is the long version of what to do. Down and dirty, count the decimal places and use the least number of decimal places. This finishes this video. This does require some practice, so I strongly recommend you do all the problems in the worksheet, and if you need more problems, I'll be happy to give them to you. And from this point on, your answer must always have the correct number of significant figures to get complete credit. The next section is going to be a major league review for you guys, because it's on the metric system, or SI units, which you've been taught multiple times. See you then.